I created a new mechanism for a refreshable braille display which traverses through a binary De Broglie sequence rather than having individually actuated pins. This reduces the cost and complexity of manufacturing, and I'm working with a local high school to implement this into education for the visually impaired. After many prototypes, it is now modular and easy to put together and add on to depending on the school's needs. I organized a project investigating turtle propellers and designed these in Fusion, 3D printed them, and ran aeroacoustic analysis on them. Using a Python program I wrote, which runs a fast Fourier transform and applies A weighting on our recorded acoustic data, we found that the turtle propellers do have lower OASBL. I also conducted CFD using lattice Boltzmann solver, and there's a clear reduction in vorticity for the turtle propellers compared to the conventional, while they do have similar thrust. With a friend, I also created an ionic thruster which uses solid-state propulsion, exploding 400,000 volts to create ionic wind. It develops a Naka 4412 airfoil profile and is surprisingly strong. One of my longest running projects is a 60OF robotic arm I made with a friend. We designed all of the parts from scratch in Fusion 360, from the actuators to the electronics. Most of the parts are 3D printed, but some of them are laser cut. My focus was in mechanics and control, and for actuation I designed 26:1 cyclotron reducers for NEMA stepper motors. For the perfect size and reduction ratio, I created my own epitrochoid function generator for the gear profiles. It uses Fusion 360's equation-driven curve plugin in the Desmos API. With these parametric functions, users can input a specific radius, eccentricity, pin size, and tooth number. While my teensy is fried, here's a video of my cyclotron actuators working on Sahil's arm. I also used it for the trochoid curves in this pneumatic liquid piston engine I made with acrylic and CO2 lasers.